Hi, my name is Ramli and I want to present part A, which is describing and summarized data. This sample data that randomly taken from the production Lajak Kuruih tablet produced in December 2021, and we have made some analysis based on it. The first analysis that we have made is based on sum aspect, where we have calculated the sum of weight, sum of relative density, and sum of tensile strength using pivot table. From the result in this figure, we can clearly see that the morning shift is having the highest of production. This conclusion can be clearly proved by the count analysis in this figure, where it shows clearly that the morning shift provide the highest production. The average analysis is similar to sum and count analysis, where we have calculated the average of weight, average relative density, and relative of tensile strength using pivot table when we graphically analyze the result using pivot table. The data is next analyzed in terms of weight, which is included numerical, tabular, and graphical features. We divided them into 10 intervals and tabular form, and we can easily see that the weight with the highest frequency is 57, which is between 344 and 354. The mean, mode, and median are calculated with Excel's built-in function, but the max, mean, standard deviation, and variance are generated with a pivot table. This graph is basically tabular analysis, and it clearly reveals the maximum frequency in the range of 344 and 200 to 354. The pivot chart is used to plot this. This is relative density study, which is similar to weight analysis in that it includes tabular analysis, numerical analysis, and graphical analysis. The tensile strength analysis shown above is tabular analysis, and we can observe that the maximum frequency of tensile strength is 7.2. The function are used to determine the mean, mode, and median, while the pivot table is used to calculate the maximum mean, standard deviation, and variance. This is the outcome of our graphical analysis, which is pivot table. Finally, we can observe from the shift analysis that the morning shift has the highest productivity with a frequency of 68, followed by evening with 66 and night with 66. Evening and night produce the same amount of material, whereas the morning produce the most. I think that's all from me, and the next presenter will be Nurul Anisa.
Hello, my name is Anisa and I will present part B. So the question is, the Food and Drug Administration Authority requires that weights of standard tablets produced by manufacturers should be normally distributed with 350 mg with standard deviation of 40 mg. Present the required analysis and comment on whether there is a significant evidence that Lajak Laku tablets produced regardless of shifts in December 2021 do follow this distribution. So from the question itself, we know that the mean is 350 mg and that the standard deviation is 40 mg. And also from the data sheet, we obtain that n equals to 200. We also can come out with two hypotheses, which is the null hypothesis is the weights of standard tablets follow the normal distributions of 350 mg, and H1 is the weights of standard tablets does not follow the normal distributions of 350 mg. So from the data sheet, we can use the pivot table in Excel to find the frequency distribution as below, which is from the frequency of 8 different ranges. Following from that, the data given, we can also compute the probability, which we will use in the next step. So for the test statistics, we can first find out what is the observed frequency, which is OI. Moving on from that, the probabilities that we found beforehand is put in this table as well, and EI is the calculated is the expected or theoretical frequency, where we multiply n with probability. Lastly, we calculate the chi-square using this formula, and the total is 2.1502. Next, we calculate chi-square for alpha b using all of these that we got octane, which is the class intervals k equals to 6, v equals to 5, and alpha equals to 0.05. So from there we can get that the chi-square alpha v is 11.0705. So our criteria decision is to reject HO if chi-square is more than chi-square alpha v. So our conclusion is that chi-square is smaller than chi-square alpha v, so we accept HO. Therefore, the weights of standard tablets follow the normal distributions of 350 milligrams. Furthermore, we can also determine from the weight of tablets that there is a significant difference between the table weights, and the evidence that Lajak Laku tablets produced in December 2021 do follow the distribution. That's all from me. Next, we will move on to part C, which is presented by Iklil.
Hi, my name is Iklil and now is for part C. In part C, we can assess whether there is any significant difference in pill weight between shift using ANOVA analysis. As you can see here, first we use filter to categorize the data into distinct shifts such as evening, morning, and night. Now we come out with the hypothesis, which is H0. There is no significant difference between the tablet weight from the different shift at alpha is 0.05, which is H0 is equal mu1 equal to mu2 equal to mu3. For H1, there is significant difference between the tablet weight mg from the different shift at alpha is 0.05. H1 is equal to mu1, not equal to mu2, not equal to mu3. From the Excel output, we will reject HO if p-value is less than alpha. After some calculation from the Excel output, we found that p-value is 0.360745 is less than alpha, which is 0.05. Hence, we accept H1 and conclude that there were no significant difference in tablet weight mg from the different shift at alpha 0.05.
Assalamualaikum doctor. I will explain for part D. We will be using the regression analysis model to find the predicted value of tensile strength. So from Excel using regression analysis model, we will obtain all of these values and I will explain to you the different values later on. So for the parameters, test is carried out at 95% confidence in linear regression relationship between the dependent and independent variable. Dependent variable is tensile strength and independent variable is relative density. Linear equation for the relationship is y equal to mx plus c. For the Excel analysis for the linear equation coefficient, we will obtain y equal to 0.080895253x plus 0.018275368. So this is the line fit plot for the actual tensile strength and the predicted tensile strength. As you can see, it is in positive linear relationship. So for the estimation errors, the obtained equation does not comply with the theoretical situation for the fields accurately, but it is acceptable because the tensile strength should be 0 when the relative density is 0. Zero relative density means that there's no fields to be tested, thus the tensile strength value should be 0. So from the Excel value, this is the intercept value, and the standard error is 32.95%, and this is the gradient value, and the standard error is 0.374%. The values are valid since it results in the tensile strength value very near to 0 when the relative density value is 0 at 95% confidence. So for the predicted tensile strength from linear regression equation at 68%, this is the tensile strength that will be obtained. For the 74.3%, this is the tensile strength that we will obtain. And lastly, at 80.1%, this is the tensile strength that we will obtain. So for regression statistics summary, regression correlation coefficient R is equal to 0.83828451, and the relationship between tensile strength and relative density has strong positive relationship as shown in line fit plot. As conclusion, the linear regression model is a valid model to be used to predict the test value of the tensile strength of the field from the relative density with up to 95% confidence level. That's all from us. Thank you.